This is what we're going to talk about today. Whoa. And tomorrow. Okay? This is probably the most important feature of this chapter are similar triangles. And a lot of what we do in the next two sections are based off of triangles being similar. Okay? So let's talk about, first of all, what it means to be similar. What's true about our two shapes? If we're similar. Same angles.
And you can dilate them to be equal.
Okay, the one can be dilated to the other. Okay, so we have a scale factor. We can multiply all of the sides of one figure to get to the size of the other figure. Okay, that's called our scale factor. We can also say our sides are proportional. We can set up a proportion and all the ratios are the same. Okay, so this is going to feel a little bit deja vu-ish because you see some SSS and SAS up there. Okay, we ended the semester with triangle congruence. How to prove triangles are congruent. In this chapter, we're proving triangles similar. Okay? So, easier. Okay? So there are 3 ways to show two triangles are similar. The first one is angle, angle. And you know that this squiggle means similar? Now you do, okay? This squiggle right here means similar. It's like the squiggle that's on top of the congruent sign, right? So angle, angle. If 2 corresponding angles are congruent, then the triangles are similar. Okay? So if we look at a set of 2 triangles, if 2 sets of angles are congruent, what does that have to mean about the third? That they're congruent, right? If I have, because both triangles have to add up to 180. So if 2 are the same, then, okay, we know that the third is the same. Okay, so I want you to look at example 1 right here. Okay? Are these 2 triangles similar? Okay, well, let me ask you this. If this is 74 and this is 75, what's left over for C?
Yeah.
Oh, so let me ask this again. Are these 2 triangles similar?
Yes.
Okay, so we can say that triangle ABC is similar to triangle Yeah. Nope, they are similar because we have 2 sets of angles congruent. So this is what I want you to write. Triangle ABC is similar to triangle DEF by angle, angle.
Oh my God, guys, I can predict the future.
No, they're not the same size because our sides can be different. Do you see, like visually, doesn't it look like ABC is bigger? Because it is, okay? So the angles are the same, but the sides are not, okay? How about number 2? Do we have enough information about the angles to determine if we have similar triangles?
Yes.
Conway, why?
Because the vertical angles on X.
The vertical angles on X. So I now have 2 pairs of angles congruent. So we can say that triangle, if I call it VWX, then what order do I need to put the vertices for my next one? Did you guys not want to grab these for our notes? Like this is what we're using?
Oh, that's what we're doing.
Yeah.
Bro, come on. How do you guys not know this?
Jeez. By angle.
You guys are sucking up.
Yes. All right. I'm going to give you a second piece of blue paper. And when you get it, I want you to look at numbers 1 through 6 in your pairs, with your elbow partner. Okay?
Wait. All equal with us.
Oh, it's like, right, I play it on Roblox all the time.
You should play shrimp games.
Short games.
Shrimp.
Shrimp games.
Roblox Squid Games.
Dude, the Fortnite Squid Games, like when it first came out, was so dumb.
I know, like just the original one, not the second one.
If you like Squid Games, just watch Alice in Wonderland.
I've never.
Playing the game.
It's literally like the exact same, but it's way harder games.
Go to Korea.
Okay. So,
They're all going to be AA if.
so, one
Parallel. So it's corresponding.
okay,
And vertical angles.
What?
which means that this is congruent to this, okay?
Wait, so that means
This is this, and that means there's two angles, which means that this
I'm not
is
following.
similar by angle similarity.
wait, so
Wait, so angle D is congruent to angle F, right? And then F are congruent? Yeah.
Yes. Okay. How do you do two? Because there isn't like a Z through it, you know? Which means there isn't any angles inside. Which means no.
Wait, how would they even be?
Those are not
corresponding
parallel.
angles.
But there's not a Z through it.
Look, I'm saying like, so like,
Wait, are we talking about QLP and MLN?
can you do that?
Yeah. But wait, where are the triangles we're trying to find? Because that's a,
QPL.
that's a quadrilateral.
Yeah, QLP and LMN. It's the big triangle and then the little one.
Oh, I see.
Oh, that makes sense.
So,
Wait, and then angle
okay,
P
so,
and angle N would be
Yeah.
congruent.
Yeah, and then same with Q and wait, Q and M, and then P and N. Let me see that.
It's this one because they share the exact same lines.
okay, so yeah, so, yes.
Yeah. But all you need is one. So either one is one.
Okay, so
I feel like drawing the equal sign and then the squiggly. Okay, so this one's yes because 39 would be over here.
I agree.
Wait, how many kids are there going to be next year for geology class? Because you're the only teacher.
Yeah, so
Like a lot of kids.
probably about 30,
Wait, how many did we?
26.
There was like 30 in our class last year. There was Anthony and then there's Ice.
I don't think.
And then there's like Haley. Oh, Haley, yeah.
Yeah, Haley, I miss Haley. Haley was my neighbor.
Where did she move to?
Seward.
Her dad was
Athletic director.
It's E449.
Yeah. All right. Can you tell me, is number 1, are those two similar triangles? Okay. We have parallel line transversal. We have vertical angles. Okay, so we can say triangle, you called it CDE, is similar to triangle GFE by angle, angle. Okay? Now, number 1 is interesting. We have parallel lines again, but what kind of angles are going to be important in this set? Corresponding. So we have these two corresponding angles. We have these two corresponding angles. So we can say that triangle, if I call it LPQ, what would I have to call the next one? LNM. Yeah, so we're talking about, triangles, not a trapezoid, right? Yeah, we got to get used to, you're going to see a triangle inside of a triangle quite a few times today, okay? Don't get scared. All right, in number 3, are these two similar? What? Because isn't S 51 degrees? Right? So we have triangle YES is similar to triangle C. Yes, Chu.
Oh, God. Yes.
All right, what about number 4? What's left over for angle B?
It's 5 degrees off.
58? Oh, that's a bummer. All right, so we don't have the same angle, so we cannot say that this is true. What about number 5?
Yes.
If I look at the tiny triangle, what's left over for this angle? 22. If these were parallel, those would be the same angles. So no. So no. All right, and then number 6. What important? But thank you. I'm not finding my words, but you know what I'm saying. Okay, vertical angles we have. Triangle XQP, if I call it that, then what would I call the other one? XYZ. Okay, honestly, this is the easiest way to tell whether triangles are similar. It takes the least amount of work. Okay, let's go back to our horizontal page. Okay, maybe we know nothing about our angles and we have some information about our sides. If all 3 sets of corresponding sides are proportional, then we can say, all right, our triangles are similar, okay? What does that mean to be proportional? To be proportional, that means every ratio is the same. So if I set up these ratios, 3 corresponds with 6, 4 corresponds with, and 5 corresponds with. If these are all equivalent ratios, then we are proportional. Is that true? Yes. Okay, so yes, that is a true statement. So triangle QPR is similar to triangle TSU by side, side, side.
Yeah, because it can be like.
Okay, and if you're not sure, you could put 3/6 into your calculator, and it should give you the same thing as 4/8, should give you the same thing as 5/10, right? Now, we're with it enough to know that those are all 1/2, all right? But that could be a shortcut for you, all right? So let's look at this example 4 here. If I make my ratios of 30/24 and 35/28 and 32 over 25.
You can't simplify 32 over 25.
Is he right? So this one cannot be simplified.
No.
But these can be simplified to be 5/4 and 5/4. This one does not equal 5/4. So no, those are not similar. Okay. All right, so go to the other sheet. And I want you to turn to the back side. And I want you to try. You know what? We're not going to do every single example on this page because I don't think that that is the best use of our time. So what I'm going to do is I'm going to have you do 9 and 10. If you think you need a calculator for any of this, then just walk your 2 legs up here and maybe get one for you and if anybody else needs one at your table.
Wait a minute. Because no. 9 is a number.
Wait, which one is the good? Which one? Is it 10 to 12 or is it 16?
9's no.
Yeah, 9's no, because 7 is larger
Okay,
than 5.
are you the one that sent me a message?
Dude, what?
Okay, go for it.
It's not the same size.
Yeah, see, that's not the same side.
You have to rotate it.
It's still not correct, sir.
Wait, 16 goes to 10, 12 goes to 7, right?
Yes, but it's still not correct.
Oh wait. I was thinking.
Yeah, number 9, one of them is rotated.
Because I was thinking like flipping it up.
Yeah, it's
Did a cartwheel, didn't it?
5/3 is bigger.
No, I was thinking about just like going like.
Flipping it up, but it's still
Do this.
He just told me to do this.
I wouldn't.
Yeah. Okay. It's long, so it's like. 16,
I'm glad to see your eyes.
and then
What?
Yeah, I need to.
Yeah. His hair's short enough I can see his eyes.
12 and 7, and then
wait.
5 and 3.
Is it 43.2 over 12?
I think so.
Or 18 over 5?
Is it that way or is it that way?
Wait, hold on. Is that correct? That might be
Is it
correct.
5 over 18 or 18 over 5?
Which one are you guys talking about? 9?
10.
Where you do 9?
The rotate the triangle and match it.
Yeah.
Yeah. So 16 and 10 go together. Two biggest numbers.
Yeah.
16 over 10.
Yeah, and then
12 over 7.
12 is then 5.
It's actually correct. 10
Are
is
they
yes.
opposite?
10 is yes.
But it's not the same.
Okay, 9 is no, and then 10 is yes.
Wait, can you do it?
I'm pretty sure.
So 43.2 goes with 12.
Okay. Micah, do you have a question? Yeah, got some right here.
Oh, yeah,
All right.
You can't do it either way.
In number 9, what are you getting? No. All right, what did you match 12 up with? 12 and 7 correspond. Okay, these the one triangle is dilated and rotated. What about 16? 16 over 10. And then 5 over 3. Okay, and you're telling me that these don't equal? Do 2 of them equal? Not even 2 of them equal? Okay, they're not similar. All right. Now, what about number 10? Are these 2 similar? Okay, if we take 12 over 43.2 and 15 over 54 and 5 over 18, you're telling me that those all 3 ratios are the same? Okay, so yes, triangle A, RP is similar to triangle TRY. Try. Bye. Side, side, side. The R's need to be in the same place because their angles are vertical. Okay.
You're vertical.
Ah, you're vertical. All right. Now let's go to our last one. Side angle side. Okay. This should be fairly self-explanatory, right? Two corresponding sides are proportional. And this is important. The included angle is congruent. Okay? So you're used to side angle side from when we did congruent triangles, right? So this example 5 right here. So we have our included angle, yes? Okay? Is 8/6 equivalent to 20/15? So this reduces to 4/3 and this reduces to 4/3. Yep. So we can say that triangle KJL is similar to triangle NMP by side angle side similarity. Okay. Now, what I'm going to do is I'm going to go back to our other blue sheet, and I want you to look at number 14. In number 14, it looks like we know 2 of each side. Well, I don't know all 3 sides, so it can't be SSS. Do you agree? So our only option is maybe side angle side. But what's the problem? Yes. We have vertical angles, but what'd you say? Say it louder, Conway.
Angles aren't between the numbers. The sides.
Not in between our sides. Yeah, no bad words. So no, these are not similar. Okay? Yeah.
Wouldn't SA work if you had a right triangle?
Well, if we had a right triangle, we'd have angle, angle.
Oh, yeah.
Yeah. I know, that's what makes it nice. Okay?
Angle, only right triangle?
No, angle, angle can be. He asked about 2 sides in an angle if it was a right triangle. Okay?
Right.
Number 18, this is weird. I only know 2 sides from each. Do I have an angle?
Yes.
We share angle L. So we have this red triangle, and technically, if I redraw it, our big triangle is GBL 39 and 34. Okay. So is 30/39 equivalent to 27/34?
Hold on.
Nope. You can still
That's sad. Okay. Now, okay. Go to number 16. I want you to determine if number 16.
Number 16.
Yes.
Wait, so which side is equal to which side?
So the bigger of the 2 is going to correspond to the bigger of the 2 over there.
Oh,
Right?
that makes sense.
If you're not sure which side of the 2 biggest are going to pair up and the 2 smallest are going to pair up. Sometimes logic is there, we just gotta find it.
Do the calculations, Chase.
Do it the wrong way back there.
Okay, yep.
I don't think congruent's the right word.
No, similar.
Oh wait, it's yes. You gotta write it down on your paper.
Guys, it's all now.
No.
So triangle EFG is similar to triangle uh-oh. What is it similar to? KJH? Okay, I'm hearing some differing opinions.
J. JKH.
E to F. Small sign. Should be JKH. Okay. Now, what if I told you, hey, FE has a measure of 35. How would we find JK?
It's 35.
I'm just,
You divide by 1.5.
let's do this. Let's set up a proportion. So if we know that this is 35 and we don't know what this is,
Multiply by.
hold on. We know that the ratio of 50 over 35 should be the same as our ratio 35 over x. Do you agree? So we can, what is this called? Uh-oh, why did I put 35? Oh.
You missed so much.
So 50x equals, oh. Take my calculator.
Just like
1, 2, 2, 5. So what is x? 24.5? Okay.
it's right there.
So we can set up a proportion if we are missing one of the sides. Okay.
Yes, I know.
All right. So please turn in your student companion to page 174.
Is that a homework?
Yes.
That is your homework.
This one.
1 through 9. 1 through 9.
Yeah. Oh, the whole page. Not taking anything out today. Now, tomorrow we are going to have a graded assignment on the computer. So, there's your warning. We got to try it out. Because remember, we're the test